Okay, gang, let's do your circular motion test review. Your test is either Tuesday or Wednesday, depending on whether you're A or B day. You'll have 10 multiple choice questions and 10 problems that you'll have to pick 8 of. So it'll be 80 points of workout problems and it will be 20 points of multiple choice. And so it'll be concepts like we've been talking about in class. All right, so let's start with the first question that um, talks about Kent leaning back in his swivel chair and spinning around with a frequency of. So we're given a frequency of 0.5 hertz. And we are asked how long will it take to make one complete revolution? Well, one complete revolution would be his period. So period is 1 over F. So we would take 1 divided by 0.5, and we would get an answer of 2 seconds. Now we're told if he spins around for 5 seconds, so he has a total amount of time, and we know that to do 1 it takes, so the amount of time for 1. Okay, total time we're told is 5 seconds, and we know to do 1 turn it takes 2 seconds. So how many revolutions will he be able to do? 2.5 revolutions, or spins. All right, that was number 1. So remember your definitions. Frequency is number of revolutions or cycles over seconds. Okay, so it is typically has the units of a hertz, all right, or cycles per second or revolutions per second, but it has to be in seconds. Period. Oops, this is F. This is T. Period is the time for one full revolution. And this is measured in seconds. All right. So it's basic reminder. Make sure you know those definitional information as well as how to apply it. Okay. Number 2, we have Curtis with his disco record. A record. Y'all don't even know what records are anymore. I need to change this to a CD, don't I? Something. But okay. Number 2. Number 2, we're told that that there's a radius to the scratch of 12 centimeters. You have to change that to meters, so it's 0.12 because you divide by 100 to get it into meters. And we are told that it skips 45 times each minute, so that is a frequency because 45 cycles per minute. Now that means we're going to have to divide by 60 to cancel out. Here, let me do that differently. I want to go ahead and say for every 1 minute, this is a skip. All right, over 60 seconds. So we can cancel out our minutes and we can find out that it takes 0.75 hertz is our frequency because it skips per second. And so it asks, what is the period of this? So period would be 1 over F. So 1 divided by 0.75 would give us an answer of 1.33 seconds. So that is our period. And then we're also finding, so this was A, for part B, it wants us to find the linear speed. Well, the linear speed is going to be V equals 2 pi RF, or we could use V equals 2 pi R divided by T. Whichever formula you like, or whichever one's easiest for you, works. Okay, so with this, I used this second one just because. So I used 2 pi times 0.12 divided by 1.33. And that gave me an answer of 0.57 meters per second. You could have done the same thing, but just done 2 pi times 0.12 times 0.75, and you should get roughly the same answer, if not exactly the same. Okay, so again, you can pick and choose the formula. I normally go back and double check those. Okay, after checking this, it doesn't matter which way you do it, you'll get the same answer. So, moving on. Number 3, Missy's favorite ride at the Montgomery County Fair, look at that, is the Rotor, which has a radius of, so we're going to put our radius down here as 4 meters. The ride takes 2 seconds to make one revolution. Since it's telling me about one cycle or one complete revolution, that is the period of 2 seconds. What is the period of the motion? Okay, well, we automatically have that. This is A. It's just being able to identify. What's the frequency? So B, it's the inverse. So 1 frequency equals 1 divided by T. So 1 divided by 2 would give us a 0.5 hertz. Okay, then C, what is Missy's linear speed when she's riding it? So speed is, let's do 2 pi r divided by T. So that's 2 pi times 4 divided by 2. So that's going to give me an answer of 12.57 meters per second. Then we're also asked to solve for centripetal acceleration. Centripetal acceleration's formula is v squared divided by r. So plug in what you got from C, 12.57 divided by your r, which is 4. We'll give you, oops, make sure you square it. Ooh, that's a common mistake. I almost missed it. Bad. All right. And you get 39.48 meters per second squared. Okay. Now, if you use the manipulated equation, I believe, which is 4 pi squared r over t squared, I think when you do that, you get the answer a little bit different and it ends up being like 39.50. So just be aware of that. I'm aware of that when I do my calculations. So, all right, moving on. Number 4 has Captain Chip. He's a pilot of this really big jet plane, which has a mass of 60,500 kilograms. So those are good units. We can leave them as is. And he unfortunately is told that he has to wait his turn before he can land at the local airport. So he has to fly the plane in a big circle. The radius of that circle, they tell you, is 50 kilometers. There is a typo. There's no M on the paper. Sorry. It's okay. All right. Kilometers is 1,000. So for every 1 kilometer, we have to convert. For every 1 kilometer, there's 1,000 meters. And so that'd be 50,000 meters. I know that seems a lot, but that's really how wide the plane has to fly. And he does this once every 30 minutes. So we have a period because he does it once. We have 30 minutes, and we don't like minutes. We have to convert to seconds. So for every 1 minute, we have 60 seconds. So we cancel that out and we multiply, and we get 1,800 seconds. Okay. That he has to fly around in this circle. All right. We're asked to find the centripetal force that the air is going to apply, which is MAC. Well, we don't have AC. So we could go ahead and say instead that centripetal force is mass times velocity squared over r. Well, we don't have velocity either. Well, you can do two things. You can go ahead and do the FC equals M 4 pi r over pi squared over t squared. I don't like doing that though because I get all confused. So I just solve for v first, and it's 2 pi r over t. So I can solve for that by saying 2 pi times 50,000 divided by my 1800 is going to give me 174.53 meters per second. Then I can go ahead and plug that in up here. So I have to square this and divide by the radius of 50,000. And then I can go ahead and multiply by the mass of 60,500. And when I do all of that math, I can go ahead and find out that the um, centripetal force is 36,857.47 newtons. And that would be my answer. So I like to find the V first, then I go ahead and square it and plug it in as I go along. So that's kind of, I do some short steps or some shortcuts, but not completely. So just realize that you have to have the right formulas. I won't give you these on the test. I will give you this one. I give you this one. Oh, let me take that back. I don't even give you this one. I give you this one actually. So I give you these two formulas so that you can manipulate them accordingly. So, yeah. All right. Moving on, number 6, because we're omitting number 5 because I didn't put the diagram on there. Sorry. So let's go to number 6. And number 6 says in our great little information, a water faucet is turned on when a force of 2 newtons, so we have a force given of 2 newtons, exerted on the handle, which is a distance of, so we're given a distance, or it says from the pivot point, so this is a radius of 0.06 meters. How much torque, so we want to find torque, does the handle, is needed to turn the handle. So torque would be force times radius. So we have 2 times 0.06 equals, and we get an answer of 0.12, and this would be in joules, or it could also be in Newton meters. All right, so you do also get this formula on the test. So, cool enough? I think that was one of our problems, like on our additional problems too. Okay, number 7. Let's use green. Can we see green on here? Oh, we can. Bright green. Okay. On number 7, we are told that Prissy, what a name, Prissy, who has a mass of 60 kilograms, is working at a construction site. She's a tough gal. She sits down for a bite to eat, and she sits at the very end of a 3-meter long plank. So we have the 3 meters long. The whole thing is 3 meters. And she's going to sit down on the end. So Prissy is located here. And we want to find out that's pivoted in the middle with a sawhorse. So that is at 1.5 meters. That's important to realize. How much torque must her coworker provide to get the other end of the plank to keep it from falling to the ground? So the coworker is going to be over here. If that's the case, then torque is force times radius, okay? And the torque that Prissy has must equal the torque of her coworker to keep it balanced. So the force that Prissy has would be 60 times 10 would be her force. And then her distance or radius from the pivot point would be 1.5. That all has to equal the torque of her coworker. So when you do your multiplication, 600 times 1.5 is going to give you an answer of 900 joules or 900 Newton meters. Okay. Number 8. Okay. Number 8 is the mobile problem, where we're hanging things above the crib. And again, these are so you can start thinking about drawing them yourself. Christina's building a mobile to hang over the baby's crib. She's going to hang a sailboat and a toy truck on it. All right. If we don't talk about the bar having any mass really, where does she have to hold the string to keep it level? So we have our bar, and we're told that this bar is how long? Let's look. 0.5 meters. 0.5 meters long. Okay. We're going to have our little toy sailboat, and it's going to be in 0.01. So we're going to come over, and it says from the left-hand side, so 0.01 meters in. We're going to hang our sailboat. I know, don't make fun of my pictures. We're told that it is 0.02 kilograms, so that means it is 2 newtons worth of force, or 0.2 newtons worth of force when we multiply it by 10. Now we're going to come in from the right-hand side, and it says when we come in 2 meters, so let's come right here. So this is 2 meters in. Excuse me, 0.2 meters in. We are going to hang our toy truck. Again, don't make fun of my vehicles. All right, so there's my little toy truck. We want to know, we're also told about our toy truck that it is 0.015 kilograms, which means it's 0.15 newtons. All right, so thing to realize is that if we have both of these things pulling downwards, then the total force pulling downwards is 0.35 newtons. So if that's the case, then we must have 0.35 newtons going upwards to keep it from moving up and down, which we don't want it to do. So we need to figure out if that yellow line that I just drew is the string, where do we put it on here? Key to this problem is you have to pick a pivot point from one end or the other. I typically will pick things on my left end just because of the fact that I like to read from left to right. And so it's easier for me to think about it that way. You can do it whichever way you want, but that's where I'm going to put the pivot point for this problem. But pick an end. Don't try to put it somewhere in the middle, okay? Pick an end. So if that's the case, we're going to say from the pivot point, we are going to find the torque for the sailboat, plus then we're also going to have to find the torque for my support string, so I'm going to say SS, plus the torque of the toy truck, all have to equal 0. All right. If that's the case, let's do the sailboat. The torque, remember, is force times radius, and that radius is from the pivot point or from the fulcrum. All right. So going back to the problem. Force of the sailboat, we said, is 0.2. Distance from the fulcrum to the sailboat is 0.01. All right. Then we're going to add. We're going to add the force of the support string, which we know to be a 0.35. Now we're going to make it negative because it's going up. We want to find the radius or the distance from the pivot point to that line. We're then going to find the torque of the truck, and we're told that the truck has a force of 0.15 newtons because we calculated it. And now, this is where this becomes important. We want to go from this pivot point in black over to this line where the toy truck is being held. okay? If that's the case, we're going to have to do 0.5 subtract 0.2 to find out that this distance is 0.3 meters. That's what we have to use in the problem down here. And all of this is going to equal 0. When we do the algebra on this one, it's important that you take it in pieces and do it properly. Okay, so when you have it, you have 0.002 plus negative 0.35r plus 0.045 equals 0. All right. Roughly another way to think about this would be, let me do it in my calculator because I don't have any more written on my page. 0.002 plus 0.045 equals, we have 0.047 equals 0.35r. And all I did was move this over here. So I added 0.35r to this side, and whatever you do to one side, you have to do the other. Then to isolate my variable, I have to divide by 0.35 on both sides. And you get an answer of 0.13 meters. That's where the support string should be put. Now it is important that you tell me what end you did this from. So I'm going to say from the left. Okay. You could say from the end with the sailboat, whatever, but you have to talk about from the left end. Sorry. All right. Take your time on these problems. Draw the drawing. Be specific. Work it out. Okay? Moving on. Number 9. Number 9. Number 9 has Hank and Anita, the paramedics. Okay? This is our stretcher problem. So again, we have the stretcher. We are told that the stretcher is 2.6 meters long. Okay? We are also told that it has a mass of 3 kilograms. The stretcher does. If that's the case, where is the center of gravity on the stretcher? Hopefully at home you're saying, it's in the middle, Miss C. Okay, if it's in the middle, then I'm going to draw my force arrow for my stretcher right in the middle of this. So at 1.3 meters, I'm going to say there's 30 newtons of force being applied by the stretcher. Okay? Now, we are going to say, I want to do letters Anita here and Hank here. All right? We're told that they're rushing a 60 kilogram man. So let's make the man green. So 60 kilograms would be his mass. And that we are told that the man's center of mass is 1 meter from Anita. So I'm going to go in 1 meter from Anita and put his force line. Okay. Now, could I have drawn his force line straight down instead? Sure. I can do that. And I'll even do that just to show that that makes a little more sense. Okay. So the man's center of gravity is here. And his is 600 newtons. All right. Now those lines are not drawn appropriately, but y'all get the idea. All right. We want to know how much force Anita and Hank have to exert to keep him level. Problem right now is we don't have a pivot point. Again, pick an end. I pick the left end always, but that doesn't have to be what you pick. You can get the same answers without doing that. All right, so we're going to take Anita completely out of the equation at this point. All right, and we're going to, again, do our torques. The first torque that we come to is the man, plus the torque of the stretcher, plus what I didn't draw in here was the force that Anita and Hank are applying. Okay, so the next one that I will be doing will be, let's say they're going up like this. Okay, so the next one would be the torque for Hank. All of these have to equal 0. Again, torque is force times radius, or distance from the pivot point. So for the man, we have a force of 600, and he's how far? From Anita, he's a meter, plus the torque of the stretcher. Now the stretcher is 30 newtons force, and how far is the stretcher's line from the fulcrum? It is 1.3, because we had to use it as a center of gravity. And then Hank is the force we're trying to find, and the distance of 2.6, because he's all the way on the other end. Well, all that's going to equal 0. Again, do your math properly. So now it's just algebra, and we are going to say that we have 600 plus our 39, I believe. Let's double check that in my calculator really, really quick. 30 times 1.3. Yep, 39. Plus my FH times 2.6 equals 0. So we have 639, okay, plus FH times 2.6 equals 0. So we're going to subtract 639 from both sides. Then we're going to divide by 2.6 to isolate the variable. And we're going to get an answer for the force of Hank to be a negative 384.23 newtons. All right. Now, does it make sense that this answer is negative? It should, because what direction is this arrow going? It is going up. So that would mean we're going to make it negative. Okay. Now, to find the force of Anita, the force of Hank plus the force of Anita all have to equal the downward force, so that the guy doesn't go bouncing up and down. Okay? So the downward forces, the two arrows that I have are the green and the white one. And so adding 630 would mean that they all have to equal 630. So I'm going to say 630 minus just my 384.23. Now, why do I not use the negative value of that? Because the negative is just there to tell me direction. It is not part of the calculation. All right? So when I do the 630 minus the force of Hank, I'm going to get that Anita's force is, oops, that's bad. I did the calculation wrong. That's what I get for not doing this. 639, I just looked off my paper, divided by 2.6 is not, I'll be hollering. If y'all are not hollering, I don't know what you're doing, okay? Y'all should have been hollering at me, because this is not this value here. Okay, stop it. That value should be 245.77 newtons negative. So instead of having this down here, we should now have 245.77. I hope a lot of y'all were yelling at me, because if you weren't, I'm going to be really upset. Okay, so we subtract 630, and we have that we get Anita's force. Come on, let's see, get it right. To be 384.23 newtons. Again, it is negative, because her arrow is going upwards as well. All right. So I made a calculation error because I was looking at my paper wrong and I got them backwards. Sorry. Okay. Good deal. Hopefully. Moving on. Number 10, last one we're going to talk about. We have doorknobs. And doorknobs are placed at the side of the door opposite the hinges instead of in the center of the door. Why? Well, hopefully everybody's saying because, Miss C, it gives you a bigger fill in the blank door. All right. So A's answer, bigger torque. Okay. So since it gives you a bigger torque because of the larger R value, it's one of those things that it should be a little, well, I hate to say easier. It just has a larger turning radius, so it allows you to push through a longer amount. So it seems like it's less work. Maybe I should say it that way. All right. Now B. B says if a torque of 1.2 Newton meters is required. So we have torque. Oops, make that right. Torque equals 1.2 Newton meters. And it's required how much force must be exerted on a doorknob that is 0.76 meters from the hinges. Okay, so that would mean my radius is 0.76 meters from the hinges. And they want to find out how much force it is. Well, it says how much force compared to, must be exerted from the hinges compared to the doorknob in the middle of the door at that. Okay, well, let's find this one first. Torque equals force times radius. So we're going to have 1.2 divided by 0.76 equals. All right, when we do that, we should get a calculation of 1.58 newtons. All right. Now, if we say that we have the same amount of torque of 1.2 Newton meters, but now we've put the doorknob at 0.38 meters, what's the force required? So torque equals force divided by radius. So we have 1.2 divided by 0.38, which equals 3.16 newtons. So when you look at it, you have to apply less force with the one that is further away. Because of the torque, if the torque value stays the same, the further the radius is, the less force you have to apply. So that's the thing to think about, is it's going to seem easier because there's less force to apply. Okay, so it says how much force must be exerted on the doorknob from the hinges compared to, well, it's less. How much you could subtract, those kind of things. So that's comparing them by showing them. All right. Otherwise, I'd read over your notes, which are on the web as well. Print them out, read over them. Definitely try to look at those last slides. We didn't really go over those, but you should read through that information and look at those animations on the PowerPoints that are on my web. All right. Check y'all later. Bye.